So welcome back, everybody. All right, we are going to focus on acid-base balances, so get ready. So it is now time for acid-base balances, which I think a lot of students just are like, oh, I do not want to do this. And it can be really confusing. So I'm hoping that after this section, and we're just going to keep this to a little section and then answer questions about it. But my hope is that after this, you can be like, okay, I get that. That is totally manageable. And this is something that's really important in medicine. So I consider this high yield. So I'm excited to dig in it with you. All right, so when we think about acid-base balances, first thing to keep in mind is when something is acidic, that means it has a low pH, right? The more alkaline it is, the higher the pH, okay? Let's just get that out of the way. And then the other thing too is that we're going to focus on respiratory alkalosis and acidosis, and then metabolic alkalosis and acidosis. Now, we're going to start with respiratory because that's the section that we're in. So when we talk about respiratory acidosis, when the respiratory is there, you need to be thinking it's caused by a respiratory problem. And so here, respiratory acidosis is caused by hypoventilation. All right, hypoventilation. And when you have hypoventilation, you get an increase in CO2. Because if you have low breathing, then you're holding in CO2 in the body because you're not inhaling enough oxygen. All right, so it's caused by hypoventilation. So someone's passed out or they're in a bad temperature state. Okay, those are things that can cause hypoventilation. But the thing then is that we have to compensate for this. And so when we talk about respiratory behaviors, our kidneys are going to be the ones that compensate for it. So here, the kidneys are going to be responding by the nephron in terms of what it intakes or does not intake back into the body. And we're going to talk about nephron in a little bit. But if you're in the state of acidosis, that means that you have too much acid in the body, and so you are going to pee out hydrogen ions. You are going to keep back bicarb. And so bicarb is going to be absorbed back into the body, which then can help neutralize that acidic environment. All right? Does that make sense? All right, good. So let's keep moving on then. So let's do the opposite of that. So then we talk about respiratory alkalosis. So respiratory alkalosis, that means that you have too much or too little CO2. You have too little CO2. If you have too little CO2, you're in an alkaline state or higher pH, right? That makes sense. And so this is caused by hyperventilation. So this is a person that's like breathing and they're so anxious. And you're like, here, breathe into a paper sack. And they're like, why? Well, here's the point of it, is because if you're breathing out CO2 into a paper bag and breathing back in from that paper bag, you're breathing back in CO2 instead of oxygen. And that is going to help you bring you back to an acidotic state. Well, not an acidotic state, but bring you back down to normal. Okay. So then also what's your nephron going to do? How are our kidneys going to compensate for this? Well, remember, if you're in an alkalotic state, what do you want bicarb to do? You want more or less bicarb in the body, right? You want less, right? So you're going to start peeing out bicarb. And again, the less bicarb you have, you can hopefully get that alkaline state into a neutral state, okay? And again, respiratory alkalosis, then we think decreased CO2, increased pH, pee more bicarb out, all right? Make sense? Good. So let's switch gears a little bit. So now we're going to talk about the metabolic states. Now, the first one we're going to talk about is metabolic acidosis. So again, acidotic state, so you have decreased pH, and usually this is due to something like diarrhea, all right? So for whatever reason, you have a loss of bicarb. Now, in this case then, you're going to have a decreased pH, and your lungs are what's going to start compensating for you. So do you think you're going to increase ventilation, or do you think you're going to decrease ventilation? Right, you're going to increase ventilation, because remember, an increased ventilation, we talked about hyperventilation, and that caused respiratory alkalosis. So if we're in a metabolic acidotic state, we want more oxygen built up in our body. So your respiratory system is going to start breathing quicker. All right, good. Also then your kidneys can still compensate, and so you're going to have less, if you're in an acidotic state, you're going to excrete more hydrogen out, hold on to more bicarb. All right, good. Last one. Here we're talking about metabolic alkalosis. Now, metabolic alkalosis is usually then you have a high pH because you have too much bicarb or too little hydrogen ions. So somebody that's throwing up a lot, so lots of gastric mucosa flying out. Or if you have too much antacids, we have this a lot with people just swallowing tons of antacids, okay? They can get into a metabolic alkalosis state. All right, so when we do this, then what is your lungs gonna do? Right, you are going to slow down your breathing, okay? When you slow down your breathing, then it causes the amount of dissolved CO2 to change, right? So again, alkalotic state, we need more CO2 in the bloodstream. And then also your urinary system can kind of perk up here too, because if you're in alkalotic state, you want to pee out bicarb, right? Again, it's whole thing about taking it back to neutral. And then one other thing I'll say too about metabolic acidosis, this would be like your ketoacidosis as well. So you notice those ketoacidotic patients, they're compensating by increasing ventilation. So they oftentimes you'll see these patients with really short, shallow breaths. All right? So that's kind of the big picture for acid-base balances. So when you think about them, think, is it respiratory or metabolic in nature? How am I compensating for it? And is my pH high or low? And what does my bicarbon, CO2, and oxygen have to do to get me back to normal? All right? So that's the process I want you to be thinking about as you answer these questions. And when you come back from the questions, we're going to switch gears a little bit into the circulatory system.